Hi class, here we are at the beginning of Chapter 8. Chapter 8 is going to be a lot of trigonometry, but before we get into that, we're going to do some work with geometric mean. The geometric mean is when the two means in a proportion are the same number. If you remember from last chapter where we had a proportion and we talked about how these two numbers and these two spots were the means and the other two numbers were the extremes. For the geometric mean, those two numbers are going to be exactly the same. So when we're solving geometric mean problems, we're going to have the same number in both of those spots. In this case, I put x, and x is the geometric mean of A and B. So when we solve this, we're going to cross multiply. We're going to end up with x squared equal to A times B. And then to solve this, we're going to take the square root. And we're only talking about the positive square root of that answer. So when you're doing these and you're setting them up, I have a few examples here. We'll just go through these real quick. When we want to find the geometric mean of these two numbers, what you can do is you can just set it up as a proportion. Put x in both of those spots because I want to know what the geometric mean is, and I'm going to put 18 and 12 in those other places. One thing that you will need to know about this is we are not going to just be rounding this to the nearest decimal. I do want these in radical form. So when that applies, we're going to be simplifying the radicals, and we'll go over that a little bit. We did some of that in Chapter 0. But I know that's been a little while ago. So I grabbed a calculator here just in case. If I want to multiply 8 times 12, I get 96. So we have x squared equal to 96. And again, I do not just want to figure out that this is about 9 point whatever that's going to be. I want to actually simplify this radical. So I need to think to myself, out of the list of perfect squares, so 1, 4, 9, 16, 25, 36, just 2 times 2, 3 times 3, 4 times 4. Which one of these is going to go into 96? And if I'm not quite sure, what you could always do is you can just start to divide. So 96 divided by 4. That works, but I also want to know if there's something bigger. I know that there is, so I would keep going. 96 divided by 9. Okay, that doesn't divide evenly. What about 96 divided by 16? Okay, that goes in evenly, and there's no other perfect squares that go into 6. So what I would do is I would take that 96 and I would break that down into the square root of 16 times the square root of 6. And then I can give my answer that the answer to this is going to be 4 times the square root of 6, or 4 radical 6. You won't have to do these for all of them. Sometimes they'll work out a little nicer, but a lot of times you will. You're going to have to kind of simplify that radical. For this next one, finding the geometric mean, again, you put both means as x, and the other numbers are 5 and 7. So when I cross multiply here, I get x squared equals to 35, and then I'm going to take the square root. Again, don't just want to give that as a decimal. I actually want to see, can I simplify this? And again, if you're not quite sure, just grab your calculator. Doesn't take too long. You can do 35 divided by 4. Nope, that doesn't work. 35 divided by 9. Nope. 35 divided by 16. I wouldn't keep guessing here because I've kind of already gone through all the options. So this will not work to simplify it anymore. So your answer for 1, if you have it like this, would just be the square root of 35. And that would be your final answer. And for this next one, finding the geometric mean here, same thing. Put x in place of both of those means and put 4 and 9. So x squared equals 36, And in this case, you'll like this one because the square root of 36 is simply 6. And you can just write that down and you're good to go with that one. For this next one, the directions change a little bit. It says now 5 is the geometric mean of 8 and what number? So when I set this one up, instead of having x and x here, I'm going to have 5 and 5 because the geometric means that same number of 8 and what number? So I'll set it up like this. When I'm solving this, I'm going to write 8x equals 25, and then just to solve, I'm just going to have to go through algebra and solve that. I have to divide by 8, and I will just type this into the calculator because I know I'm going to get a decimal. And for this one, it'd be okay to write it as a decimal. For the other ones, because they're not an exact decimal, that's where you want to leave it in radical form. Okay, and next I will show you how we will use this when we're solving questions with triangles. Here, the directions say they want me to write a similarity statement identifying all 3 similar right triangles in the figure. And there actually are 3 triangles here. Sometimes kids just see 2. There's this one that's here in blue, there's this one here in red, and then there's the entire whole big right triangle. So before I do that, I would strongly encourage you, especially if you have a hard time kind of visualizing this, to draw these 3 triangles out separately, but draw them to where they look like they're all like rotated and reflected the same way. And in this case, I would kind of exaggerate that there's a shorter side and a longer side and make sure that I put a right angle on each one. And I know I wasn't using my straight line tool, so just kind of do your best also. And I would go through and label these, so when the actual work of writing out this statement comes, it'll go really fast. So for this biggest triangle, that would be the F and the G and the H. I've already drawn it like that first one, so I'm just going to go ahead and label those F, G, and H. For this next one, again, this is why I wanted you to kind of exaggerate which one's the shorter leg and which one's the longer leg. Usually you can tell where G is, or where that right angle is. In this case, the shorter one is JG, and that longer one is GH. If it's not as obvious which one's shorter or longer and you're having a hard time, just remember H and H, because they're the same angle, need to be in that same position. And for this last one, again, J is the right angle. Looking at these 2 letters here, the shorter side is FJ, or you could think J has to be in that same, or F has to be in that same position, and then that leaves G for the other one. So when I'm writing my similarity statement, and remember that was the whole purpose of this, I'm just going to have to go around in some sort of order. I'll start here at the top and go down and then over to the right. So triangle FGH is similar to triangle GJH, which is similar to triangle FJG. So now we're going to plug some numbers in here, and I'm going to show you how we can write some proportions to solve, because really these are just similar triangles. This section's kind of the bridge between last chapter and what we're going to do with triangle things in chapter 8. On the second page of notes, I'm going to kind of show you 2 different ways to do the same thing. The first way is just still thinking about what proportions are. I have this triangle that was split into 2 drawn out where you have all 3 triangles drawn separately. And what we want to do is we want to write the different proportions for all of these. So this first one, it wants me to give the proportion of the shorter leg to the longer leg. And I'm going to go through and just do that for each triangle. So here I have B over A, I have X over H, and then I have H over Y. Again, I'm just looking at the shorter leg to the longer leg each and every time and writing that as a proportion. For this next one, it wants me to give the hypotenuse to the short leg. So again, I'm just going to fill that in. So the hypotenuse to the short leg will be C over B. The hypotenuse to the short leg will be B over X. And then here, the hypotenuse to the short leg will be A over H. So just going through and doing that. And then this last one, it says the hypotenuse to the long leg. So that is going to be the hypotenuse to the long leg, C over A, B over H, and A over Y. So you may be wondering why this is tied in with geometric mean, and it's because we can actually kind of use these shortcuts, and instead of having to think about this stuff every time and draw them out separately every time, we can use these special ratios to be able to figure out some of these problems when the triangle looks like this. So for this first one, hopefully maybe you can tell if you kind of put a box or a circle around this, H is in the same position. So this here will be the geometric mean. So looking back to this picture, this H is the geometric mean of Y and Z. And that is our first of these two theorems. It says the geometric mean for the altitude theorem. And it says the altitude drawn to this base separates the hypotenuse into two segments. And this altitude splits it to where it ends up being the geometric mean between the lengths of those segments. When I draw this out, what I usually do is I'll write down that the altitude is the geometric mean, so I just go ahead and put it in both of those spots, of the two segments of the hypotenuse. So if I'm abbreviating it out while we work in class, this is the way I'm going to write it, but that's the way it is here. Whatever that altitude is that splits that triangle into two, it's the geometric mean of both of those two parts there. This next one is just kind of an example for both of the next scenarios. You can see here that B is a geometric mean if I'm just looking at those two parts. Or if I kind of cross off this middle, we have A as a geometric mean for C and Y. So looking up to this picture, here we have B, and B is this leg. It's the geometric mean of this whole distance and X, so the part that's right next to B. Or if I'm looking at this one here, A is the geometric mean of the whole thing, C, and Y, so the part that's right next to that. So I need to scroll down a little bit, but kind of hang on to this thought as I do that. So that is exactly what this says. For this one here, it's the geometric mean for the leg theorem, and it says again the altitude's drawn in to the hypotenuse of a right triangle, separates it into two segments. The length of the leg, so the leg, like B or like A, is the geometric mean of the length of the whole hypotenuse and the segment of the hypotenuse that's adjacent to that leg. So B was the geometric mean. This leg is the geometric mean of the whole hypotenuse, and I abbreviate it by putting like the segment adjacent. So the one that's adjacent to B is X, or the one that's adjacent to A is Y. So here's how the questions are going to look. And just like before, because we're doing geometric mean, I don't want these numbers as decimals. I would like to have them as simplified radicals when we can. Sometimes they'll work out to be exact whole numbers, and that's fine. Let me grab the calculator again just so we have that. And here we go. When I look at this, I always find the altitude first, just because I think that that's easier. And in this case, the altitude is Z. And I'll go ahead and kind of write my abbreviation up here again. You probably still have it, but because I had to scroll down, it kind of changed. So this altitude is the geometric mean. So I'm going to put a Z in both of those spots for the geometric mean. And it's the geometric mean of the two segments that that whole hypotenuse was split into. So in this case, it is 8 and 25. And it doesn't matter the order that you write that, because we're just going to be multiplying.
So Z squared equals the square root of 200 and Z equals 10 times the square root of 2.
And you're done with a third of this problem. I still need to go back and solve for y and x, and it doesn't really matter for this one which order I do these. Again, just a personal preference, I like to start with the altitude when I can. Okay, for that next one is a leg. So the leg is the geometric mean of the whole hypotenuse. So what is the length of that whole hypotenuse there? Well, you need to add the 8 and the 25 together to get that. So that's going to be 33. So it's the whole hypotenuse, 33, and the segment of that that's adjacent to x. And in this case, that is 8. So I will use the calculator on this one. We have 33 times 8. X squared equals 264. And then if you're not quite sure if that's a perfect square, one thing you could do is just try it. And this one here is not a perfect square, so I need to go back through and see if I can find some number that divides evenly into 264. I probably wouldn't start down at 4 because I might be working on this for a while. I might try 16 and see if 16 goes into it. Nope, that one doesn't. I would keep trying maybe some different even numbers, like 36, and see if 36 goes into it, and that one doesn't either. Like maybe we just go back and try 4. That's 66. It didn't look like anything bigger than that went into this, so I can rewrite this as x squared equals, and I'm going to split this up into 4 times 66. So when I take the square root of each side, I have 2 times the square root of 66, and that's going to be all that that one can simplify down to. For that next one, that last one, again, I have a leg. So when I put this in, I'm going to put the leg as the geometric mean, and I'm going to put that same number in both of those spots. And this is the geometric mean of the whole thing, 33 and 25. So when I'm solving this, what I'm doing is I'm multiplying those together and then taking the square root. So 33 times 25 is 825. And again, I'm going to go through and I'm going to see what types of perfect squares go into that. If you're not quite sure, again, it might be a good idea just to kind of check and make sure that's not a perfect square, and in this case it's not, but that might be a good option, especially if you don't know all your perfect squares by heart. I know 25 goes into it 33 times because that's what I ended up doing, and if you want to like do some more double checking, think about like, is there any perfect square that goes into 33? And there's not. So sometimes it's just kind of one of the perfect squares is what you multiply. This is going to be the square root of 25 times the square root of 33. So the final answer, the way I'd want you to write it, is 5 radical 33. And it will not be full credit if those are not in radical form. For this next one, for this one here, I again always start with the altitude, but in this case you have what the altitude is. So you don't need to put an x there, you would put 12 there for each part. And it's the geometric mean of both of the segments of the hypotenuse. So in this case that ends up being x and 9. When I cross multiply, 9x equals 144, and then you can just take 144 divided by 9 and you get 16. So I would go ahead and fill that in, that x equals 16, because it is going to be necessary that you have that if you want to keep using the geometric mean. Some people might say at this point that they would just use Pythagorean theorem, and that is a possibility. I'm going to show this as if we were doing geometric mean, just so you can see it. But if this were a test or a quiz or something, if you come up with the answer a different method, I'm not going to really care, but you will have to use geometric mean for at least one of them, if not more than one. So let's do y next. Y is a leg of this whole big triangle. So I'm going to put that in both of these spots. I need to find the whole hypotenuse. So that whole hypotenuse is 25. And then the segment that's adjacent to y is 16. When I solve this and I multiply, this ends up being a perfect square. So after you solve it, you should get y to equal 20, because that ends up being 400, and then take the square root of 400. And for this last one, for z, z is a leg, and it's the leg of the geometric mean, which is, the geometric mean of the whole hypotenuse, which is 25, and then the segment that's adjacent to z, which is 9. So here when I cross multiply, I get z squared equal to, this is going to be 225, and then when I take the square root of that, I should get 15 for my final answer, because it's the square root of 225. So I hope this helps. I'm expecting questions that I would love to help you guys with when you're working on this. Thanks for watching.